Unit 7.3 is similar polygons. Similar polygons. Similar means same shape. Same shape. If you recall, congruent was same size, same shape. The thing that made them the same shape was the fact that corresponding angles are equal. So the little symbol for similar was that squiggly. Remember, a congruent had equal, which means the sides were equal, and the squiggly, which means that the angles were equal. So this was the same size part of congruent, and this was the same shape part. If we have only the same shape part, then we're talking about similarity rather than congruency. Okay? So similar polygons are polygons that are the same shape. In similar polygons, corresponding angles are equal, which is what gives them that shape again. And corresponding sides are in proportion, in proportion. When we're talking about proportion, and we're really thinking that one got bigger than the other. If we went from little to big, we would say that we scaled up. Or if we went from big to little, we would say that we scaled down. And so we're going to talk about a scale factor that we use to scale up or down, or talk about proportionality. Now, in testing, as we talked about before, with the percentages, in the early days of testing, as far as my teaching career is concerned, just about everything was proportions. Now we're leaning more into using algebraic equations or scaling up and down using a scale factor, or what we call dimensional analysis. And so what we're going to do is we're going to use both proportions and dimensional analysis here, just as I did in my Algebra 1 text. So we'll try to get you used to both scenarios. So let's look at this first example. It says that triangle ABC is similar to triangle DEF. Now what that means is that they're the same shape, not necessarily the same size. If they're the same shape, then corresponding angles are equal. So angle A is equal to angle D. First goes with first, see? And we kind of did it like this earlier with the congruency. We just say, okay, we're going to color code it. Angle A is equal to angle D because they're both first, and angle B is equal to angle E because they're both second, and angle C is equal to angle F because they're both third. And you could look in the picture and see that their measures are the same. A and D were both 50, B and E are both 70, C and F are both 60 in the picture. And then the sides are in proportion. The sides are in proportion. So side AB, we go to side what? Well, we can just look at how they're named similar and see that AB is the first two letters, so it would connect to DE, the first two letters. BC, the second two letters, would be go with EF, the second two letters. So we can name the extended proportion, as we call it, showing that the sides are in proportion, just by looking at how they're named similar here, you see. And so AC, first and last, would go to DF, which is first and last. And so we untangled the proportion or the picture by looking at how they were named similar. In the picture, it may not be every time that the left corresponds to the left or the right to the right, because the triangle may be flipped around or spun or something like that. So then what we would do is we would go to the picture and we'd say, okay, what about AB in the picture? Well, AB in the picture is 12, so we can get our numbers in our proportion right, you see? And this is, again, what we did in Algebra 1 on page 57 of the Algebra 1 text. So then DE is 6, and so we have 12 is to 6 as BC is 10, is to EF 5, as AC 14 is to DF, which is 7. Now you can see that they all reduce to 2 over 1. So we say that the 2 over 1 is the scale factor between triangle ABC and DEF. Now, that's actually incorrect, because if we go from ABC to DEF, that's going from big to little, which is scaling down. And if you scale down, you use the reciprocal 1/2. If you went from DEF to ABC, the scale factor would be 2 over 1, because you would be going from little to big, or scaling up. Okay? So the scale factor is the ratio of 2 to 1, but we use that ratio 2 over 1, or its reciprocal 1 over 2, if we're going from the big triangle to the little triangle. Then we would be scaling down, so we would use a scale factor of 1/2. If we were going from the little triangle to the big triangle, we would be scaling up, so we'd use the scale of 2 over 3, of 2 over 1, excuse me. In other words, if I wanted to go from the 10 to its corresponding side 5, big to little, I would multiply by the scale of 1/2. Or if I was going from the 6 to that side, I would multiply by the scale of 2 over 1 to get bigger. See? So scaling up, you'd multiply by 2. Scaling down, you'd multiply by 1/2. Any questions on that? So they reduced to 2 over 1, so we say the scale factor is 2 over 1, but we got to remember that it may not be the 2 over 1 we use. It may be the reciprocal 1 over 2. And more specifically, if we're going from ABC to DEF, we are going from larger to smaller. So we would say the scale factor is 1/2. Had it said of triangle DEF to triangle ABC, there we would be going from smaller to larger, and that's when the scale factor would actually be the 2 over 1. Okay? All right, let's look at example 2. We're just matching up the sides here. You may think, well, GH goes to LK, but let's look. GH is the first 2 letters in the similarity. The first 2 letters in the second one is JK. GH corresponds to JK, not KL. So the left did not match the left. You can't just look at the picture. You have to look at how they're named similar. And then HI is the last 2 letters. It goes to KL, the last 2 letters. And first and last GI would be with first and last JL. Okay? So GH, which is 12, corresponds to JK, which we don't know, so we're going to leave it JK. HI, which we don't know, corresponds to KL, which we don't know. We don't know either one of those. GI is 8. It corresponds to JL. GI corresponds to JL, which is 5. Now, this is the pair we know. So our scale factor, if we wanted to use a scale factor, is either 8 over 5 or 5 over 8. That's the scale factor. We'll use it in a moment for dimensional analysis down here at the bottom. Right now it says set up a proportion. Now, to set up a proportion, we're going to use the two pairs of sides. So we're going to use this pair and this pair. Now, the given pair is this, and so we can say 8 is to 5 as 12 is to JK. Now, we went from side of big to side of little with the 8 and 5, so we have to go side of big, side of little with the 12 to JK, okay? Now, to solve a proportion, you cross multiply. JK times 8 is 8JK is equal to 5 times 12, which is 60. Now we're going to undo multiplication by division. We get JK equal 60 divided by 8. And so when we take the 60 divided by 8, we get 7. 7 eighths are 56 with 4 left over. You put your remainder 4 over your divisor 8, and so we get 4 and 1/2 or 4.5. So we could leave the answer. This is, excuse me, this was a 7. We put the remainder 4 over the divisor 8. We got 7 and 1/2 reduced, or 7.5 as a decimal. If you took the 60 over 8, excuse me, and reduced, you could divide by 4 and you would get 15 over 2. So your optional answers are 7.5, 7.5, or 15 over 2. Okay? Now, instead of using a proportion, we could have used what we call dimensional analysis. And this is important because this is the way you do conversions and changes in science. It's also the way they're leaning towards on a lot of the standardized testing these days. We could say, okay, I want to solve here. I want to go from the 12 to its partner JK. So I'm going to start with the 12. And the way we do dimensional analysis is start times scale. Start times scale. So we're starting with the 12 over 1, and we want to multiply by the scale. So we think, I'm trying to go from 12 to its partner JK. Now that's going from the big triangle to the little triangle. So I need to get smaller, and so I'm going to scale down. Now, I'm either going to use a scale factor of 8/5 or 5/8, you see, because the pair I knew was the 8 and the 5. If I'm scaling down, I need to get smaller, so I'll multiply by the smaller of the two 5/8. So we take what we start with, the 12. We want to scale down to its partner JK. We scale down using the small version of the scale factor. So 4 goes into 8 twice. 4 goes into 12 3 times. You multiply and you get 15 over 2, which is fine to leave improper or make again a mixed numeral 7 and 1/2 or a decimal 7.5. Any questions on using proportions in similar triangles or using scale factors in similar triangles? Both are important for you to know. Okay, let's go to the daily work. It gives us a congruency there on numbers 1 through 4. I mean a similarity, and you want to name the angles that are equal, and name the extended proportion. Let's go ahead and just do the second one because it asks for the scale factor, and it specifically says triangle ABC to DEF. So let's take a look at that. If these are similar, the little squiggly symbol means similar, which means same shape. If they are similar, then corresponding angles are equal. So angle D, which was first, would correspond to angle A, which is first. Now, it asks for the degrees, though, and so angle D would be equal to angle A. Angle D would be equal to angle A because they were both named first. Therefore, if angle A is 50 degrees, then angle D would be 50 degrees. Angle E. Angle E was named in the middle. It corresponds then to B because it was in the middle. If B is 60 degrees, then angle E must also be 60 degrees. Angle F is last. It corresponds to C, which was last. If angle C is 70 degrees, then angle F must also be 70 degrees. In similar figures, corresponding angles are equal. Now, it asks for side DE and side EF. Now, they're not the same. They're not equal to the sides of the other triangle. They're in proportion with the other sides in the triangle. So we can't just say DE is equal to its corresponding side AB. We have to understand the proportionality, okay? So what we would do is we would say, well, AB, first two letters in the first triangle would correspond to DE, first two letters of the second one, and BC, last two letters, would correspond to EF, last two letters, and AC, first two letters of the first and last letter of the first one, would correspond to DF, first and last letter of the second one. So then we could go to the picture and pull in our numbers. AB in the picture was 7. DE in the picture we don't know. BC in the picture is 5. EF in the picture we don't know. AC in the picture is 6. DF in the picture is 10. The one we knew both of, we can reduce, and that becomes our scale. And so our scale factor is either 3/5 or 5/3, depending on if we're scaling up or scaling down. Now this question right here, it says the scale factor of ABC to DEF. ABC is the little one, DEF is the big one, so the scale factor that would take you from the little one to the big one is the 5/3. The scale would be the 5/3 because when you go from ABC to DEF, you're trying to get bigger, and so you would need to multiply by the bigger version. Okay? Any questions so far? So then how do we find DE and EF? Well, we can do it with proportions, or we can do it with dimensional analysis by scaling up or scaling down. Let's do it both ways. Let's look at DE. Again, this is on page 57 of the Algebra 1 text. If we're going to use a proportion, then what we're going to do as we look for DE is we're going to find the proportion with the ratio with DE in it. So we're going to say 7 over DE, excuse me, we're going to say 7 over DE is equal to, now, if we're going to set up a proportion, this is where we have to be careful. We put side of little over side of big. Therefore, when we go grab that 3/5 or 5/3, we have to put side of little over side of big. Remember, in a proportion, it has to be the same two comparisons of the same two items. And you've got to get stuff right. Top over bottom equal top over bottom, bottom over top equal bottom over top, top plus bottom over bottom equal top plus bottom over bottom. Or if you're going to do this, you're going to say side of little over side of big, then you have to have side of little over side of big. To solve a proportion, we cross multiply. 5 times 7 is 35, is equal to DE times 3, which is 3DE. And now we're going to undo multiplication by division, and we're going to get DE is equal to 11 and 2/3. 11 and 2/3. Now, if I use dimensional analysis to solve, then instead of setting up a proportion, I do start times scale. And so I would be thinking this, I'm looking for DEs, but I'm going to start with its partner 7. And I'm trying to go to DE. Now DE is the side of the bigger. So I'm trying to go from a side of the little to a side of the big, so I'm scaling up. If I'm scaling up, I'm going to use the scale factor of 5/3. So I'm going to multiply by that scale of 5/3, which would give me 35/3, which you can see is the same as that right there. And so the result again is 11 and 2/3. Okay? Any questions on that? Okay? Okay, so now we're going to find EF. We'll use a proportion and dimensional analysis both again. Okay, so this time we want to find EF. So when we're looking for EF, we're going to find the ratio with EF in it if we're going to do a proportion. So the ratio with EF in it is 5 over EF. Now we analyze a bit. That's going from little triangle to big, so we got little over big. So we're going to use the little over big version of our scale, because if we're going to set up a proportion, we say little over big equal little over big. And then we cross multiply. 5 times 5 is 25, equal 3EF. Now we're going to undo multiplication by division, and we get EF is equal to 3/8 or 24. You'd have 1 left over. Put your remainder 1 over your divisor 3, 8 and 1/3. With dimensional analysis, we would do start times scale. We're going to start with its partner. We're looking for EF, and its partner is 5. We're going to multiply by the scale, and when we're going from 5 to EF, we're going from little to big, so we're scaling up. So we're going to use the big version of the scale 5/3, and we get that 25/3 again, which is 8 1/3. Okay? So again, we're going to continue to show you the using a proportion method and the dimensional analysis method. We want you to be familiar with both and understand the concept of the scale factor. Okay? We have some more for you to practice here, and you probably need that practice. So we're just going to let you do the rest on your own.